Good afternoon, everybody. So we're going to continue with the map project that we were working on Wednesday. Excuse me. And so that's our main goal today. But happy Friday. Made it through week 2 of fall 2020, and things are looking up. Things are starting to change, and I really think the future is looking bright. So we'll continue with our map on how many cows and where are they in a few minutes. But before you do that, I want to show you a new feature that I added to Sakai, a new resource that I added to Sakai, which will help you study and learn GIS definitions and concepts. All right, let's go to it. So here is Sakai, and I am in the Lessons tab, and under week 2 I put a link to a Google Slides presentation that I'll work on and just add to. Key GIS terms and concepts. If you click there, well, I'm logged in. I'm the owner, so I can change it and make changes. But you'll see something more like this. And right now, it's just definitions that we've encountered, and 3 pages. And I'll keep adding more and more and more to this. So this last definition, choropleth map, it's a kind of thematic map where you got polygons on the map, and the polygons represent geographic locations, and they're color coded to represent some sort of attribute associated with each of the polygons, each of the extent of the geographic locations represented by each polygon, and that's what we're working on with the cow map. All right, so that's there, and focus is all whack. That's there, and I will be adding to it as we go on. So end of week 2, your first exam and your first lab practicum are less than 3 weeks out now. Less than 3 weeks out. So it's not too far away. But you'll be ready. I know you'll be ready. So if you got any questions, put them in the comments. I see them here, and I will try not to lose track. Okay, so let's go to my messy desktop and open up ArcGIS Pro. And open up our project that we were working on last time. It's called Cows of America. Getting notification there's an update. I will do that later. Okay, and so here we are. And so this is where we left off last time. We had just to review a little bit, we had started by importing the polygon data for the 50 United States, including Alaska and Hawaii, and the attribute table associated with this data has lots of information, but we wanted to attach information about from the USDA, NASS, cattle, including calves, yearly or biannual inventory to each state, and that took a little bit of doing because we had to, in order to merge data from a table to the attribute table associated with one of our layers, the 2 data sources have to have something in common so that you can map the data from the table to the data in the attribute table. And so, and we did that. We found that there's this essentially state code. The states are all numbered alphabetically, and we could then manage this merge in that way. So let's do that again, because actually the attribute table that we're using here for the 50 United States does have population data. I know it does somewhere. It's got a lot of information. Demographic data. Yeah, population 2017. But our Cal data is from 2020. So let's find population data from 2020. And put that in here. So I got that in that same, let's see, the same folder that we added a connection to here. I have, let's take a look at this. I'm going to add this to my map and open it so we can take a look. So what this is I pulled this from the Census Bureau. So if you want population data, where is a better place to go than the census? And so the census happens every 10 years, but actually the feds make an estimate of what the population is in each state using some sort of model yearly. So I was able to download a spreadsheet, a table, a comma-separated value file with the population estimates of all 50 states, including the District of Columbia for 2020. All right, so if we look at this, we'll see that there is a column which looks just like our FIPS, not our FIPS. Where is it? Where is it? The state ANSI number. There's a column here that's just labeled state, which has the same numbering scheme. So there's a row that's got a label 0 for the entire United States. There's a row 11 for the District of Columbia. And let's see, I wonder, see there's no 11 here because we didn't have data for the District of Columbia when it came to the Cal inventory. So it just added a row as null here. So let's do this merge. So I go here and do a join. I'm going to add, and my input table is U.S. states local, and I'm going to join on the state ANSI. There it is. So you can see that the name here, it has a prefix associated with where it was originally from. It was originally from the USDA NASS state cattle inventory.csv file that we joined last time. And we're going to join this population data, and in there the field we're going to use is the state column. And let's click OK. And it took all of half a second. And now we should have, there we go. At the end, well, it looks like what we got is a population estimate for 2019. So I guess there isn't 2020 data, but 2019 is better than 2020. So let's go with it. All right. So we just did another join. Okay, so we got data from another source. We want to put it into our attribute table associated with the polygons of the 50 states. Now, okay, let's refresh our memories. What are we ultimately trying to do? We wanted to see, remember one of the questions we had was, what is the ratio between cows and people, cow population, people population? The question was, are there any states that have more cows than people? In which case that ratio would be larger than 1. Okay, So, oh, I see there's a question here. Hold on. Gracie, are lecture exams going to be more based on the PowerPoint you just showed, like terms and concepts? Yes, yes, they are. So the practicums will be apply what you've learned to perform some tasks using ArcGIS Pro and ArcGIS Online. And the exams will be mostly multiple choice or fill in the blank, focused on concepts and definitions. Okay. Anyway, so what we want to accomplish here is actually a calculation. We want a ratio. We want to calculate the ratio of cow population to people population, cows over people. Okay, so we can do that, and we did this once last time where our goal was to reformat one of the columns so that we changed it from being a text string to being a numerical value. And so what we're going to do now is just that same idea, just a little bit more sophisticated. So what we'll do is we'll go in here and let me close this so I don't get confused. In our attribute table for US states local, I'm going to add a field, and I'm going to call it cow to people ratio. I'll use the same alias. And I'll make it of type float. Float is a data type that's numerical and has decimal points, decimal places. And I'll click save. All right, this will create that field, but there'll be no values in it yet. So we'll see that. See, cow to people ratio is just null. So now I right click here, and I'm going to do calculate this field value. And this will be, let's see, cows. So cows are in this column labeled just value. I'll divide by, so I hit this little button here to divide by, and then I'll find the population estimate in 2019, double click. Okay, and there we go. So let's see, just quickly, you probably can't see this too well because it's probably super tiny on your screen, but there are in fact several entries. South Dakota's, this ratio is above 4. So I did not expect that. So in South Dakota, there are 4.4 cows for every human. Nebraska, there's 3.5 cows for every human. So not only are there states that have more cows than people, there's states where people are really outnumbered by their cows. So I hope cows never become super intelligent and want to overthrow their masters, or everyone's going to wish they were vegetarian. Okay. So, all right. Does anybody have any questions about what we just did here? So, thus far, we did another example of what we did last time of combining data from a table and a data frame. And we did a calculated column. We calculated, if you've ever done any work in Excel, you might be pretty comfortable with this concept, but you can calculate values in one column using values in other columns. Looking at your comments here. You're all very quiet on this Friday afternoon. Okay. So let's continue. All right. All right. So let's think about a little bit more carefully about what we want to visualize now. So this type of map, like I said earlier, is a choropleth map, and it's a kind of thematic map, which is it's using color coding to show a value of some attribute in each of the polygons. So they're very common, and but there's other types of thematic maps, and actually, let's do this. So the number of cattle, that's just sort of like a magnitude. How many cattle are there? It's a magnitude. So one way that and you guys did this in the first week of lab in lesson 1 in the project workbook. A really effective way to communicate magnitudes is by using this strategy called graduated symbols, where you have circles or any other shape, and they're bigger if that quantity is larger in that area, and smaller if they're not. So this is actually a good way to communicate the number of cows in each state. I guess you could think of it as like, if you got all the cows in one place, how much area would they take up? Well, not really, but it's analogous way of thinking. All right. So I'm going to go in here to this layer, and I'm going to change the symbology. And instead of using graduated colors, I'm going to use graduated symbols. By the way, the only difference between graduated, I don't know if you can see this whole screen, you can just see the words here, graduated symbols and proportional symbols. Graduated symbols are separate the data into classes. So you have like 5, it's like a histogram. You have 5 bins, and each data point gets put in each one of the bins, and each bin has a different symbol shape and size. And proportional symbols are continuous scale. That's the only difference. So we'll do graduated symbols, and we're looking at cow population, which is the value column, and let's pick a different template here. I like this gray one. Let's do that. And let's say 5 classes. Yeah, sure, that's fine. Let's make the minimum size a little bigger and the maximum size a little bigger. Yeah, about like that. So we can really see where the cows are in Texas, Oklahoma, Kansas, California, Nebraska. That looks pretty good. There's a little bit of transparency on these symbols, and I'm okay with that. We could change that if we wanted. We use natural breaks for now. That naturally it defines the limits of our categories automatically. So we could change the labels here, like these. Maybe this is like, if we wanted to say, instead of less than 480,000, we could say 0 to 480K. Abbreviate K for 1,000. And in here we could do, so this would really be 480K to 2.2 million, or 2,200K. And I'm not going to do the rest, but you could do that. So you see how that changes the legend over here. And I can change this to number of cows over there. That's all I'll do right now. But you can change the label for your legend over here in the classes table. Okay, so there's we have an interesting problem right now, and it comes from this. So the layer that's on my, think of layers on your map. They're like the fundamental components of your map. Your map is composed of raster, layers of raster and vector data, and then the base layer, the base map is usually a raster layer too. It's an image. And so any given layer, in my contents pane, I can choose a symbology for any given layer. And but in this case, we have an interesting problem in that there's actually we want to visualize on our map two different columns of our attribute table at the same time. And but I can't do that with a single layer. Here I'm visualizing the number of cows using these graduated symbols in all the 50 states. And so now if I wanted to visualize the cow to people ratio, I couldn't do that because I'm already visualizing it I'm already visualizing something else in this attribute table. So it's an interesting problem, but it's not a really big problem. So what you can do in ArcGIS Pro and ArcGIS Online is you can add the same feature class. In this case, it's the US States Local feature class, which is attached to this layer. You can just add it multiple times to your map, and then you can visualize those layers differently. So like this. All right, so I already, let's see. So I created this feature class that resides in this Cows of America geodatabase, and it's called US States Local. And then if you remember from last time, I added a copy of it to my map here, and I never renamed it, but basically the purpose of this layer was to visualize number of cows. I'll just write that again. I know it's a little redundant now. Here I could say thousands, and then here I could drop the K. So I got this heading and these subheadings to contend with. Anyway, perhaps you get the idea. But I want to visualize this other dimension of this feature class, US States Local, as well. So I'll just take it and put another copy on the map, and there it is. Okay, so I'll call this cows per person, cows per person. And now right click on this and let's do symbology. And so here let's make this a choropleth. So we're going to want graduated colors based on the cow to people ratio, natural breaks, that's fine, and we'll keep the default color scheme in classes, 5 classes, and we'll just leave it at that. Okay, and so this is a cool map. So what do we notice? Well, we notice that the northern plain states, people are really outnumbered by cows, and California's got a lot of cows. That circle's big. It's got somewhere between 4 million and 7 million cows, but there's a lot of people there, so the cow to people ratio is less than 0.13. And West Virginia, what's our cow to people ratio here? Our cow to people ratio. Why can't I find it? I feel like I keep going past it. Let's click on West Virginia. I'm looking for West Virginia in my feature table here, or my attribute table. There you are, West Virginia. There are 0.22 cows, less than a quarter cow per person in West Virginia. West Virginia doesn't have a lot of cows, nor does it have a lot of people. We're a small state as far as cows and people are concerned. Sean, could you change the values of the cow to people ratio to have one color show a greater than 1-to-1 ratio? Yeah, that's actually good. Let's do that. So Sean's question is, you know, so this is really good. The interesting thing is, you know, which states have more cows than people? And so let's the way you would do that is instead of having the built-in algorithm pick your classes, you would manually do that. So let's do that. Okay, so we'll go into, oh, it's already open, the symbology. So instead of doing natural breaks, let's do create, well, let's do defined interval will work here, and we'll do our interval size of 1. Okay, and so we could do manual, but here if we want to just do uniform intervals, we could just do this defined interval, and now the interval, so this yellowish color is places where people outnumber cows, and everything else is where people are outnumbered by cows. And the darker the color, the more outnumbered they are. So South Dakota has more than 4 cows per person, and Oklahoma, Kansas, and Nebraska, they're pretty outnumbered there too. Okay, is that so? Yeah, Sean, you can do that. And here, you know, if you wanted to change this to just you know, manual intervals, you could come in here and you could set the values manually. I think that's a better color scheme. Warning, warning, there's too many cows. Let's keep it like that. Oh, that's kind of pretty. Okay, so I'll save my work here. All right, we got about 20 minutes. So the next thing we want to do is let's learn something new. And you know, what the point of making a map is to hopefully learn something about data that has some sort of geospatial aspect, you know, a geographic location associated with it, but you know, it's not unusual that you want to share your map, right? You don't want to just keep it to yourself. So the old-fashioned way of sharing things, you know, before there was an internet, you could just hit a button and upload your map to ArcGIS Online, would be for you to create some sort of document that you could then make copies of and distribute to the world. And so in ArcGIS Pro, you can turn a map into what's referred to as a layout. And a layout has, think of it as, you know, it becomes like a Word document where there's a window, in this document which shows your map, and then you can add other things like the legend. You can add a compass rose. You could add a scale bar to show scale, and you could even add other maps, you know, inlets or inset maps and things like that. So let's do that. Okay, so what we're going to do is up here, we're going to go to Insert on the menu bar and insert a new layout. And let's make it landscape, but just normal paper size. Okay, 8.5 by 11. And I want to put my map in here, so I'm going to go to map frame, and then here I can select, you know, what map do I want to put in here. Well, let's go back here first and try to get things looking. No, I don't want to have anything selected. Here we go. Just kind of center the United States. And so see, there's a tab for map and a tab for layout. And so in the layout, I will insert a map frame, and I just click and drag, and then I can move it around. But I mean, you see what this is a little window into my map, and the scaling's not quite right. I want to rescale the map so the United States, the 48 states, fit in this window here. So if I right click on here and do activate, that actually activates the map portion of this window, and now I can drag it around. I can use the wheel on my mouse to zoom in and out, be a little bit more controlled using the step zoom or fixed zoom buttons. Well, that looks pretty good. Maybe I'll come down here and like manually change the scale. Make it a, oh, I forgot how many zeros I had here. I want to zoom in a little more. All right, we'll leave it at that. So my scale is 1 to 30 million. And so then I'm done adjusting the map box. So I'm going to go up a level and just click this button here for layout, and I come back up to the layout. Now if I move the window around, the map doesn't change in the window. It's basically, at this level, it's just an image that you're moving around. And so now I'm looking at this and I'm like, well, I kind of don't like that base map. The base map, it's the topographic base map. I think I want something more simple. So what I can do is I can go back to my map layer and change it. So I'll go to base map and let's do the light gray canvas. Light gray, yeah, it's not as intrusive. You go back to layout, see, it updated. Okay. Want to add the legend. So I click the legend bar and option and just drag a box here. And I'm guessing I can't see because it's not big enough. Where is it? Huh. Here, delete. Let's try that again. Map. There we go. I hadn't selected the map that I wanted to put the legend of. So, you know, here, you know, you could, it's going to take a little doing to make this look right. But maybe I'll just put this down here for right now. So my legend shows me what my symbols and colors represent. And if this was for real, I'd want to spend a little more time formatting my legend to make it look better. You know, these titles aren't really very good for what I'm showing here. I could put in an arrow representing north, but in this case, with a thematic map, um, it doesn't really add that much. Thematic maps, choropleth maps, they're not for navigation. They're not for finding your way around. They're for communicating some kind of value associated with the geographic extent of the polygons that you're showing on the map. So it doesn't really add that much. That's my take on it. Same with a scale, a map scale. You're typically not going to use a thematic map to navigate. Okay. One thing is, the map projection that I'm using here is just a Mercator projection. You get this rectangular looking map projection. And I don't really like it. I don't really like it for this purpose. Let's make my map look more like the map that you would see on a classroom wall. So that projection is an Albers. I'll have to add that to the PowerPoint, some common map projections. But it's a conic projection. It's called Albers equal area conic projection. So the name tells you that it's a projection that's meant to preserve the fidelity of the areas of objects at the expense of other things, mainly shape and direction and distance. But it looks nice. So let's do that. So I'll go to my map here and go into properties, and there it is, coordinate system. And so I'm going to go in the search bar here, and I'm just going to type in Albers to filter stuff down. And I'm looking for a projected coordinate system. Let's look at continental North America, and let's see what we got. So down here we got the USA contiguous Albers equal area conic, and it's USGS. So this must be what the USGS uses. I don't know if it's good enough for them. It's good enough for me. So you can see that this projection is made to make North America look good, to make the United States look good. It is not made to make Europe look good, or Australia, or South America. Okay, but that's okay, because it's a good projection for our region of interest here, the 48 lower United States. So the tell for this projection is you can always tell when you're looking at this projection, because the northern border of the United States is curved down like this, and it's the northern border along Montana and North Dakota and Washington and Idaho. It's along a latitude. So you see that curved northern border, and that's a tell for this type of projection. You can tell that if I zoom out, you can tell that this projection is the result of projecting the Earth's surface onto a cone and then kind of cutting the cone in one place and splaying it out flat. It's got this kind of shape, so it's a conic projection. So I gotta adjust my the projection changes the map, so I gotta change my zoom level, my scale, now that I've changed the projection. I went off the top there. Okay, well, you get the idea. So what's missing? What's missing from my map? I want to show cows and people in the 50 United States. So what's missing? The 50 United States. I'm looking at your comments. Ugh. I'm getting hungry. It's almost pizza o'clock. Wait a minute, it's not even 2 o'clock yet. Why am I so hungry? What's missing? It's the 50 United States. Yeah, Alexis got it. Alaska and Hawaii are missing. So, all right. So one thing you could do is if you want to, let's just do Alaska. All right, let's just do Alaska. We could do Hawaii in the same way. And one thing you could do is you could just add another map frame for Alaska. So let's try that. So I'll put in a map frame down here, and then I'll just go to activate and zoom out and just kind of move until we see Alaska. All right, so you could do something like that to add Alaska, and you could do Hawaii too. And it's better than nothing, but there's a problem here, and the problem is that the projection that we're using for the 48 states, what do they call that? Contiguous United States. The projection we're using for that is not a good projection for Alaska. And so Alaska doesn't look right in our layout. So the way that you could correct this is you would make a copy of your map. So now you have two maps that are just carbon copies, and on the copy you apply a different projection, and then you use that map for Alaska. All right. So let's delete this, and we'll go over here to our map, and I'm just going to go to let me save my map here. Blah, blah, blah. And I'm just going to save that map file, and then I'm going to, where'd it go? And then I added it. All right, did you catch that? So I right click on here and I save as map file, and that creates a map file in my directory, and then I added it. Oh great, all my linkages are broken. All right. Another thing you could do, you know what? There's got to be an easier way to do this. I'm gonna figure it out. But you create a new map, and then you could add all the layers in that you want and make it look just the way you want. But we only have 5 minutes, so let's skip all that steps and let's just look at what happens if you get the projection right. Oops. Properties, coordinate system. So let's do an Albers conic. But I saw one in here. Yeah, there's one Alaska Albers equal conic. So this is one that's designed to make Alaska look right. And it does. You know, I learned something that, you know, something from the laboratory that you guys did yesterday, the westernmost point of the United States could be interpreted as the easternmost point because it's on the other side of the international date line. There's an island out here called Attu Station, or Attu Island, and there used to be I guess a Coast Guard station out there called Attu Station, and it's not inhabited anymore. But look how far away, this is out in the Aleutian Islands, it's part of Alaska. Look how far away it is from mainland Alaska. Talk about remote. All right, so now let's put in our map frame down here. And let's activate and zoom out, move things around. There we go. Now Alaska looks right. Okay, so the way to do that, I mean, there's nothing that says you can't use different projections for different frames on your layout, and they just have to come from different maps. So I could save now, and you know, this isn't very pretty. It's not, but now I want to share it. Go to share. I want to export my layout, and then I can export it as a PDF or a JPEG. Let's just do a PDF, and it's going to save it to that same directory. I'll click export. It was complete. And so let's take a look, see if we can find it. Where did I put that? There it is. Okay, so it's a nice PDF version of my map. And you know, you can make these things you know, bigger or smaller depending on your needs. So you know, at the end of the semester, you know, you guys have a lot of steps to do to conceptualize a project, to gather data, to make your map, do any analysis that you need to, and then to make your product. And one of the things that you'll make is a PDF version of your map. And if we are able to, we'll print those out and put them on the wall and share with the world. Put them on the wall over in the Snyder Hall. So next week when you guys are on campus, walking through the hall, you'll see remnants of projects from last year. I think a lot of them have fallen off the wall and have just disappeared, but some of them are still there, and that might be good thing to do to brainstorm ideas. All right, so you guys have any questions before we call it a day? We call it a week? See any. All right, so have a good weekend. I'll see you next week, and we will continue. There's one more thing we want to do with this map, and that's share it to ArcGIS online. So we'll do that next week. All right.